Hello all, let's start section 3.4. Section 3.4 is the chain rule. To be honest with you, this is the last rule of the derivatives. And the most important one was the product, the quotient rule, and next one is the chain rule. Where we use chain rule, I'll explain it to you. It looks kind of complicated, but I saw before students, or when I was in LRC, students are coming from classes, they struggle with the chain rule, but I'll try here today to explain it the way to first give you the concept of the chain rule. It means where you should use chain rule and which problems and how to use it. I'll show you two different ways of applying the chain rule to find the derivatives of a function. Let me start this way with a very simple example. For example, let me change the color first. For example, if I have a function f of x equals, let's say, the square root of x squared plus 1. To be honest with you, and all the rules that up to now you know, like the addition rule, the subtraction rule, the power rule, plus the product rule, the quotient rule, you see this problem, none of them you cannot apply on this problem to find f prime for me. It's impossible, correct? It's impossible. Why? Because which kind of function is this? If you focus, if you learned your chapter 1, which was a review, and I discussed these types of functions for you, and I named this function a composite function, it's a composition, you cannot not apply the product rule, the chain rule, or the addition rule to find the derivative of a composite function. Then, how to find the derivative of a composite function? What we use the chain rule. What does it mean? I'll explain it to you. If I kind of focus on this function, later I'll do another example. I'll show everything in the example for you. But let me explain it here. I told you that this is actually a composite function. You see, this one actually, I can say that I can write this function as a y equals f of u if I name under the square root or the square root u, and my f of u is a square root of u, and I name under the square root g of x or u equals g of x, and it's x squared plus 1. You see, I'm dealing with two functions. One is here, one is here. Here, easily I can find the derivative. Here, I can easily find the derivatives. This is how we use the chain rule, correct? This function is actually, if I name it this way, your f of x equals actually the f of g of x. You see? F of g of x. This function is f of g of x. This is a composite function, or maybe this notation, f of g. This function is f of g, correct? Now, how to deal with this problems? First, I'll do an example to kind of prove it, to show it for you. Then later, I'll give you a law or a rule easily in one sentence. You can find the derivative of any composite function, any function that's composite in the form of composite function, you can find the derivative. Let's take this example. For example, I have y equals 3x squared plus 1 to the power of, let's put a big number, to the power of 40. If it was power of 2, it's okay. I can kind of use a plus b square, and I can apply, then I can use the addition rule and find the derivative. But this is power of 40, power of 100. Do I know what is 3x squared plus 1 to the power of 40? It's really difficult to find that, right? It takes pages to do that. It takes a day to find that, right? Using the binomial formula or whatever you do, it's really difficult. You don't want to do that, correct? Now, what I do here, I'll write y equals u to the power of 40. It means I'll name the inside function, which is 3x squared plus 1. I'll name it u. Look here, u equals 3x squared plus 1. I'll do first this. I'll name 3x squared plus 1 u, and I'll get u to the power of 40. Now, they are asking you to find dy over dx, right? Or in other notation, y prime. Find the derivative of this function. Okay, I cannot find in this form, but here, can I find the derivative of this function? Y equals u to the power of 40. Can I find the derivative of this function? Y equals u to the power of 40. All of you, you know how to find this derivative. Here you can write dy over du, the derivative of this function, in respect to u equals 40 u to the power of 39. Using the power rule, right? It's really easy. You already learned this. And also at the same time, can I find the derivative of this function? U equals 3x squared plus 1. Yes, all of you, you can do that. You're looking for the du over dx, the derivative of this function in respect to x. And that will be 6x. Am I right? The derivative of 3x squared plus 1 is 6x. Now, focus here, because here I'll write the chain rule for you. What is my goal? My goal is to find dy dx. Look, my goal is to find dy over what? Dx. Equal to something, right? Here, I have dy du. Look here, I have dy du. I could find easily dy over du. If I multiply this one with this derivative, which is du dx, you see it gives me dy dx, because du cancels out with du. I'll end up with dy dx, dy over dx. Then I can write. This is kind of proof for the chain rule. Then every time that I look for the dy over dx, it means I'll take dy over du, which means the derivative of outside times du over dx, the derivative of inside. We call this formula the chain rule. This is your chain rule, nothing else. Why I did it in an example, because in your book, they use the notation of composite functions. Maybe for some of you, if you read the book, it's really difficult to find it in general form to understand what is going on. Why du dx? Why dy du? But in this example, clearly you see that what is the meaning of dy du? What is the meaning of du dx? And why dy dx is equal to dy du times du dx? We call this rule the chain rule. Or this is the Leibniz notation, right? We call this notation the Leibniz notation. This is Leibniz notation. Or you can write in prime notation, correct? Dy dx means f prime of x, right? It's the same thing, basically. Dy over du means f prime of g of x, the derivative of outside, du dx means g prime of x. This notation or this notation, both of them is chain rule. Which notation you are comfortable to use, use it. That's the chain rule. If I translate this one for you, the prime notation, this is your f prime, right? F prime of g of x. F prime means derivative of outer function, which in this example that I did for you, your outer function is that exponent that's in the top, u to the power of 40. That's your outer function. Or in this example, the square root, in my first example, the square root is the outer function, correct? Times gx. What is the meaning of gx? Gx is evaluated. You are evaluating the outer function, correct? You are taking the derivative of outer function evaluated at inner function. Let me write for you. Evaluated at inner function. Here, g prime of x, derivatives of inner function. Or in a very simple language, focus, I give you a simple language. Every time that you are taking you are using the chain rule, take the derivative of the outside times the derivative of inside. That is chain rule. Derivative of outside times the derivative of inside, correct? That's your chain rule, very simple, correct? Now, I'll do few examples for you. I doesn't want to finish this example that I start here, this one. I don't want to finish it. I just explained the chain rule. I'll start with easy examples for you, and I'll do 5 or 6 examples. Hopefully, you will be good to go with the chain rule, because I know if you go to LRC and you don't focus on this lecture, if you go to LRC and ask our tutors, yes, they can solve a problem for you, but they cannot explain to you what is chain rule, because they are students like you, correct? Then I'll do few examples, focus how I'm explaining. I'll show you 2 methods for you. Which one is easier for you? Go that way, you are good to go. Example number 1. For example, they are asking you, find the derivative of f of x equals a square root of x squared plus 1. Or let's say even, let me put this one as a y to make it easier for you. Y or f of x, everyone at this level knows y means f of x, right? They're asking you in this example to find y prime. It means find dy over what? Dx. Y prime means dy over dx. Okay, is this a composite function? Yes, it's a composite function. Then what is my rule for the composite function? I have dy over dx equals, I just gave you the rule here, dy over du times du over dx. dy over du times du over dx, correct? Now, what is my step one? If you want to go this way, do it step by step. Step one, write it as a two function, correct? Outside function, inside function. Use u, usually we use u, but you can use any letter, m, n, but be careful when you are using m, n. Also, in your formula, you should change u to m or n or whatever variable you are using. But basically, a lot of time we are using u, correct? Your u will be the inside function, which is x squared plus 1. What will be the outside? Your outside becomes as a y equals a square root of u. Everyone agrees with this notation, I think, with me. Because u is x squared plus 1. If I plug in back this here and u, it gives me the function, right? Because it's a composite function. Now, in step 2, find this derivative and find this derivative. Correct? That will be your step 2. Step 2. Let's find the derivative of this function. Y equals a square root of u. Can I write the square root of u as a u to the power of 1/2? Remember, every time in derivatives, when you are dealing with a square root, cube root, fourth root, or in general in radicals, change your radical notation to exponential form, to rational exponent. A square root means power of 1/2. Cube root means power of 1/3. Fourth root means power of 1/4, correct? First, change it to this notation. It means you will end up with y equals u to the power of 1/2. If I ask you to find dy over du, because your variable is u, everyone knows how to take this derivative based on the exponent rule. 1/2 of u to the power, you subtract 1 from 1/2, right? Let me even show how you subtract 1 here. 1/2 minus 1 gives you negative 1/2. Am I right? Or if you simplify this, dy over du equals 1 over 2 u to the power of positive 1/2. To change negative exponent, you have to send it to denominator. It's algebra, I shouldn't explain. You send the negative exponent to denominator to change it to positive denominator, a positive exponent, correct? Then you can write dy over du equals 1 over 2. What is u to the power of 1/2? It means the square root of u, correct? Let's stop here. Go find the derivative of the second function, this function. U equals x squared plus 1. U equals x squared plus 1. Look for du over dx. The derivative of this function in respect to its variable, which is x, right? What is the derivative of x squared? The derivative of x squared is 2x, and the derivative of a constant is 0. It means your du dx is 2x. Now put pieces together. Step 3. My formula was dy over dx equals dy over du times du over dx. Wow, I have du over dx. I have dy over du. Let's plug in these two values in our formula. Then I can say dy over dx equals dy du. Your dy du is 1 over 2 square root of u times du dx is 2x. Only one more step, because an original problem, we don't have u, right? My original problem is y equals a square root of x squared plus 1. Replace back or substitute back the value of u. Then dy over dx equals 1 over 2 instead of a square root of u, because u is x squared plus, it was x squared plus 1, I think, right? My u is x squared plus 1. I will write 2 square root of x squared plus 1 times 2x. Now, if you can simplify, simplify. You see, I can cancel 2 with 2. Then dy dx, which is my y prime, right, equals x over the square root of x squared plus 1. You are done. You use the chain rule to find the derivative of that function. Correct? Let me do now another example for you. Let's say example 2. They're given to you y equals sine of x squared. You see, it's a composite function because inside is x squared, the outside is sine. Correct? Use this method. This is the easiest method. After practicing few problems, then you don't need to go that way. You already know the derivative of outside. What is the outside? The outside is sine. What is the derivative of sine? Cosine. Correct? Let me first show that easy way for you. Y prime equals the derivative of outside. My outside is sine. What is the d over dx of sine? Or if I write the notation for you, d over dx of sine times d over dx of inside x squared. d dx of sine gives you cosine. Cosine of x squared times d dx of x squared is 2x. Here you go. That's your answer. If you have enough practice. If you don't, just follow the rules that I showed for you. Use the Leibniz notation. Again, I'll do it in a different way in a red color here for you. You have u equals sine of x squared. Name x squared u. Correct? Then y equals sine u. Here, two functions. Find the derivative of this one, find the derivative of this one. At the end, multiply both of them, it gives you the answer. Here, find dy over du. What is dy over du? What is the derivative of sine? The derivative of sine is cosine. Cosine u. Here, find du over dx. What is the derivative of x squared? The derivative of x squared is 2x. Now, what was your chain rule formula? My chain rule formula was dy over dx, which is y prime, right? Equals dy over du times du over dx. Bring these pieces here. Plug in this one here. Plug in this one here. Then dy dx or y prime, dy over dx, dy dx equals here cosine u times du dx, or du dx was 2x. Last step, substitute back the value of u. Dy over dx equals cosine of, what was u? Your u was x squared. Cosine of x squared times 2x. Or some people write in this notation, 2x cosine of x squared. Which way you write, both of them is the same, right? Easy, hopefully. Let me do another example. Example 3. Look, this example is different. Y equals sine square x. First of all, instead of sine square x, can I write this one as like this? Sine x all square, because that means sine square x. They are the same, right? Now you see it's a composite function. The derivative of outside times the derivative of inside. Or use the Leibniz notation. Make two functions. Y equal u, which is the outside, u squared, and name your u sine x. Correct? The inside is sine x. Here, dy over du equals 2u. Here, du over dx equals, what is the derivative of sine x? The derivative of sine x is cosine x, right? Now, formula, put the pieces together. Dy over dx equals dy over du times du over dx, which means dy over du is 2u times du over dx is cosine x. Just substitute back the value of u, which is equal to times, what was your u? Your u is, look here, your u is sine x. Then 2 sine x times what? Cosine x. That's it. That's your derivative. That's your y prime or dy dx. As long as you have the understanding of chain rule, what is chain rule? Then it gets easy. Let me do another different example for you. Example 4. Y equals e to the power of sine x. First of all, is this a composite function? Yes. What I do here, I name my exponent u, correct? My u is equal sine x, and y equals e to the power of what? U. Now, dy over du equals, what is the derivative of e to the u? Everyone knows the derivative of e to any power gives you back the same thing, e to the u. Here, what is the derivative of u? Du over dx equals, what is the derivative of sine x? The derivative of sine x is cosine x. Now, my formula, put pieces together. Dy over dx equals dy over du times du dx, which is equal. Dy du is e to the u times du dx is cosine x. Now, only substitute back the value of u here, which is e to the power of sine x times cosine x, final answer. That's your y prime or dy dx. Correct? Let me take a little bit more complicated one. Example 5. I think 5 examples should be enough for you. You don't need to go to any tutoring. But if you need still, I'm encouraging you to go ask for help, right? use my office hour. I know I missed it last week, but it will not, I was kind of had a pain in my head. I had headache and also my throat was not good. That's why even I couldn't speak well. That's why I missed my office hour. But this week I'm available, right? Anyway, let's take example number 5. Example number 5 is f of x equals sine parentheses cosine parentheses tangent x. Wow. It looks crazy, right? Sine, then cosine, then tangent. They are asking you to find f prime x. It means find y prime. Actually, here you have f of g of h of x, such a composite function. F of g of h, or in this notation, f of g of h. 3 functions, correct? When I have 3, I'll name it this way. I'll start from inside. I'll name it, for example, t. T will be tan x, correct? Then outside, if I show it with the red color, this part, from here to here, I'll name it u. Your u will be cosine of tan x, which is, I can name it cosine t, easy, because I named this part t, right? And this function will be y equals what? Sine of u. Sine of u cosine t, and t tan x. You see, I break it to 3 functions. What will be my notation? What is my goal to find? Here you see, here you are looking for the dt over what? Dx. Here you are looking for du over dt. Here you are looking for dy over dx, or du, sorry, dy over du, which gives you what? Which gives you all of them dy over what? Dx. If you multiply all these 3, at the end you see you end up with dy over dx, which is the derivative of that big function. 3 easy pieces. Okay, what is dt over dx here? What is the derivative of tangent x? The derivative of tangent x is secant square x. Please memorize the table of the derivatives of trigonometric functions. It's not just for this semester. Next semester, calculus 2. Those of you that you go to calculus 3, you are using all the time that table, correct? Then memorize it, please. Here, u equals cosine t. What is the derivative of cosine t? The derivative of cosine t is negative sine t. Here, dy over du. What is the derivative of sine u? The derivative of sine u gives you cosine u. Okay, let's put pieces together. If you put pieces together, then you are good to go, because your formula here that you create as dy over dx equals dy over du times du over dt times dt over dx, right? Put the pieces together. Dy du is cosine u. cosine u times du dt as negative sine t times dt dx as secant square x. And simplify it means substitute back the values. Cosine u, what is u? Cosine of, even you have a negative here, you can bring it to the front here. You can put the negative in the front. Cosine of u, what is u? Your u was what? Let me go up, your u as cosine t. You see your u as, let me make it smaller a little bit that you can see the top also. Your u as cosine t. Then cosine of cosine t times sine t, sine of t. What is t? Your t as tangent x. It means sine of tan x times secant square x, secant square x. One more substitution here, t. I have to put the value of t there, and then I'm good to go. That's my answer. Then this one equals negative cosine of t. My t was tangent x times sine of tangent x times secant square x, my final answer. As long as you can break it to simple pieces, you can apply the chain rule. Correct? Last part of your lecture. I'll give you another formula here. I will not going to prove it. Just memorize this formula. D over dx of the derivative of b to the power of x. Any function that's b to the power of x. B is a number. B is a constant. 2, 3, 4, 1/2, whatever that number is, to the power of x is always equals b to the power of x ln b. That's the formula. Proof, I'll show the proof in calculus 2, not in calculus 1. Correct? I can show it in calculus 2, the proof for you, not in calculus 1. Now, let's apply, let's do an example. Only one example, because this is really easy. Example. For example, if I have y equals 2 to the power of x, they're asking you to find y prime or dy dx. Then y prime equals d over dx of 2 to the power of x. Based on my formula, I have b to the power of x. It means 2 to the power of x times ln of b. How much is b? Your b is here what? 2. That's the answer. This was all about section 3.4. See you next time in a lecture and section 3.5.